So if you're working in a hybrid cloud environment, you've almost certainly run into this problem. How in the world do you get your on-premises data center and your AWS cloud to talk to each other like they're on the same team? Well, we're going to break down exactly how to solve that using a really powerful AWS service. Okay, so here's the scenario, right? You've got servers in your data center. Let's call them server.internal.example.com. And you've got databases running in your AWS VPC like db.acme.example.com. An app in the cloud needs to find that server on-prem, and maybe a user on-prem needs to hit that database in the cloud. This creates what people call a split-brain DNS situation. It's literally like your network has two different brains that can't communicate. One brain lives on-prem, the other lives in the cloud, and neither one has any idea what the other is thinking. And trust me, that is a huge headache for any hybrid setup. And that's exactly where our solution comes into play, Amazon Route 53 Resolver. You can think of it as a fully managed DNS bridge built specifically to fix that split-brain problem. It's designed to connect those two worlds, creating one single unified network, at least from a name resolution standpoint. Now here's something you might not realize. Route 53 Resolver is actually already working inside every single one of your VPCs. It's the default service that handles public domain queries and resolves your local VPC names. But the real magic, the part that makes it so powerful for hybrid cloud, comes from two other functions: its ability to conditionally forward queries out to your network and to receive queries in from your network. So how does it make all this happen? Well, it really just comes down to two fundamental building blocks. Let's break them down. We're talking about endpoints and rules. Let's start with endpoints. The easiest way to think about them is as secure doorways for your DNS traffic. That's it. Under the hood, they're just network interfaces that get a private IP address inside your VPC. They create the official entry and exit points for any DNS query that needs to travel between your AWS world and your data center. And of course, these doors swing both ways. You've got inbound endpoints, which are what your on-premises DNS servers will send queries to, letting them ask for the address of something inside your VPC. And then you have outbound endpoints, which is where queries from your VPC get sent out to find something on your on-premises network. It all just depends on the direction the query is traveling. Okay, so if endpoints are the doors, then rules are the smart traffic controllers standing right there at those doors. Their job is to look at every single DNS query that comes through and decide exactly where it needs to go based on the domain name it's asking for. So a rule is just the logic. It's a set of instructions. You basically create a rule that says something like, hey, listen up. If you see any DNS query for a name that ends in internal.example.com, don't even try to look it up yourself. Just forward it straight over to the IP addresses of my on-prem DNS servers. It's a brilliant way to tell the system how to handle different parts of your DNS namespace. All right, so we've got the individual pieces, the endpoints are the doors, the rules are the traffic hops. Now let's put it all together and actually follow a DNS query on its journey from start to finish. Okay, let's trace an outbound query. First, an EC2 instance in your VPC needs to talk to a server in your data center. It sends a query for server.internal.example.com to the default VPC resolver. That resolver checks its list of rules and bam, it finds a match for internal.example.com. Based on that rule, it immediately sends the query over to the outbound endpoint. That endpoint then pushes the query across your secure connection, whether it's a direct connect or a VPN tunnel, all the way to your on-prem DNS. The answer then just comes right back along that same path. So simple, but so effective. Now let's flip it around and look at the return trip. A client in your data center needs to find a resource in AWS. Your on-prem DNS server has been set up to forward any queries for acme.example.com to the IP address of the inbound endpoint in your VPC. So the endpoint gets the query, passes it to the Route 53 resolver, and the resolver looks up the resource in its own records, what AWS calls a private hosted zone, and sends the answer right back. You can see it's a perfectly symmetrical system. So when you kind of zoom out and look at the big picture, what does all of this really give you? It gives you a truly seamless hybrid cloud. So let's just recap the key takeaways here. By using just two simple building blocks, endpoints to create the secure pathways and rules to direct the traffic, you basically transform the default DNS server that's already in your VPC into an incredibly powerful hybrid cloud tool. And the end result is that your on-prem resources and your cloud resources can all find each other by name, just as if they were sitting in the exact same network. And ultimately, that's the whole point. Route 53 Resolver is all about bridging that DNS gap, making your hybrid setup feel less like two separate, disjointed networks and a lot more like one single cohesive system. And that leaves us with a pretty fascinating question to chew on. As tools like this make the line between the cloud and on-premises fuzzier and more transparent every day, what does that really mean for the future of the traditional data center? What's its role going to be in a truly unified hybrid world? Something to think about. Thanks for tuning in.